In this example, we've been given the equation s equals t cubed minus t squared, where s represents the displacement of an object in meters and t represents the time in hours. We need to find the velocity, specifically the instantaneous velocity, at t equals 4 hours. We start by taking the first derivative of our function and obtain ds dt equals 3t squared minus 2t. You may be asking yourselves, why are we taking the first derivative? Well, if you remember from physics class, the average velocity can be found by taking the change in displacement and dividing by the change in time, or delta s divided by delta t. Therefore, it seems logical that the instantaneous velocity would be found by finding ds dt. So we found the derivative using the power rule, and now it's just a matter of substituting in 4 for t. And we end up with an instantaneous velocity of 40 meters per hour. In the second part of this question, we've been asked to find the acceleration of the object at t equals 4 hours. From physics class, you might remember that the average acceleration is found by looking at the change in velocity with respect to a change in time. So, if we can look at the rate of change in the velocity with respect to time to find the acceleration, it would make sense that the instantaneous acceleration would be found by taking the derivative of the derivative, which would be the second derivative of our original function. So that's what we've done. If you notice, our second derivative in this case is 6t minus 2. It's merely a matter of substituting 4 in for t and solving, and we obtain 22 meters per hour squared. In the last and final part of this problem, we've been asked to find when the object is momentarily at rest. Well, when the object is momentarily at rest, its velocity should be 0. So we take our first derivative, which is our expression for our instantaneous velocity, and we set it equal to 0. So we obtain 0 equals 3t squared minus 2t. Fortunately, this particular quadratic can easily be solved by factoring. If this was not the case, we'd be forced to use the quadratic formula. When we factor and set each of the factors equal to 0 and solve for t, we obtain two answers, t equals 0 and t equals 2/3. Therefore, this object is momentarily at rest at 0 hours or at 2/3 of an hour, which can also be expressed as 40 minutes.